Related rates. So the key to related rates, it's all in the title. You have to be able to relate the rates. So for example, they might say something like, oh, for a triangle, the height is increasing at a certain value. So you have the height at some value. They might say, oh, and the base is increasing at this other value. So dB dt. They want to say, what's the change in area? So area is dA dt. What you gotta do is figure out a way to relate those things. A lot of times they give you the equation. Sometimes they don't when it's basic. So like here, I'm like, oh, I'm doing a triangle. Area equals 1/2 base times height. And then when you take a derivative of this guy, dA dt, you're going to get a little product rule here, but you're going to get a dB dt, and you could get a dH dt. It's a little product rule. Right? And then you could plug your values in. That's all it is you get an equation, or they give you an equation. You take the derivative at some point. You might have to do a little work before that. And then you just plug stuff in and solve. Like this quick example. The radius of a circle is increasing at a constant rate of 2 millimeters per second. So that right there tells me it's a related rates problem. The radius of a circle, so dr dt, is increasing, so plus, it's a positive version of this, on the right meters per second. What is the rate of increase of the area? So dA dt is I'm looking for, when the circumference is 20 pi. So use that later. So they want me to find dA dt when dr dt is that and circumference is that. Okay, so let's relate A and R with area. Area of a circle, is pi r squared. I don't have to do anything fancy, just have to take the derivative of this. So dA dt, take a derivative of that. So remember, it's a variable, so bring down the 2. Pi is a constant, stays there. R, we're taking respect to time, so that's not R, they don't match, wrong variable. So dr dt, and that's my equation. All I gotta do is plug stuff in. Well, again, I have dr dt, 0.2. I'm looking for dA dt, so that's not an issue. It's just R I need. Hey, they gave me the circumference. Circumference of a circle, if you're not sure, is 2 pi r. So that's 20 pi. You just do some math. R equals 10. So there's my R. Plug that all in, you get an answer. There you go. Let's do an actual question now, like a harder version. So let's look at this one from the 2002 test. So give us a little picture here, and they want to tell us a ship A is traveling due west, so ship A, at a speed of 15 kilometers per hour, and ship B is traveling due north on a speed of 10 kilometers per hour. So basically, it's all this, right? So this is a related race question. Now they tell us ship A is the speed of 15 kilometers. So A is this one, so dx right that way. The rate dx dt is 15. And over here they tell us ship B is going 10 kilometers. So dy dt, so fast it's going up, dy dt is 10 kilometers per hour. Let's do the first question. Find the distance in kilometers between ship A and ship B when x is 4 and y is 3. So we're telling, hey, when this happens to be 4 and this happens to be 3, how far apart are these guys? So this is like an Algebra 1 question, right? This is the Pythagorean theorem. You just go, okay. Because how far apart they are is this right here. Let's call it z. So you just do x squared plus y squared equals z squared. And that's a 3, 4, 5 triangle, so I'm just going to say z equals 5. No work needed. B, find the rate of change in kilometers per hour in the distance between the two shifts when. So now they want to find dz dt, the rate of change. So B is find dz dt when that's 3 and that's 4. So again, I got to relate these things, and we kind of redid it. The way you relate these guys is x squared plus y squared equals z squared. Right? You got to be able to relate the stuff you have on there. So that's a triangle. So x squared plus y squared equals z squared. So then all I'm going to do here is take a derivative like we always do. So 2x, wrong variable with respect to t, so dx dt, plus 2y, wrong variable, dy dt, equals 2z, wrong variable, dz dt. Now you could divide all the 2's out, so you're just going to get x plus that, but whatever, I'll do that in a second. Now we got to plug stuff in. Now again, they gave us most of this. dx dt over there, 15. X, for this, remember they said when x is 4, so that's 4. y, I'm going to divide all the 2s to pretend they're not there. Y they gave us is 3. dy dt they gave us in the very first part of the problem is 10. We just found out z was 5, and they want us to find dy dt. Right, so you just divide all this by 5, and you get your answer. You can figure it out, you can leave it like that, either way is fine. Unless it's calculating, actually has plenty of calculator, but that's the idea. Right, C, the angle shown in the figure. Find the rate of change of theta in radians per hour when x is 4 and y is 3. So for C here, you need an equation, because we want to find the rate of change of theta, so we need the theta dt. So similar idea. I got to find an equation with theta in this. Well, how goes your trig? I got tan here. So I got tan theta equals y over x. So I need d theta dt, so I gotta take the derivative of tan to get rid of the, so I gotta take the derivative of both sides. The derivative of tan is secant squared theta. Now, to the little chain rule, take the derivative of the inside, leave the inside alone, times by the derivative of the, take the derivative of the outside, leave the inside alone, times by the derivative of the inside. Derivative of theta is just 1 d theta dt because of the wrong variable. And on this side, that's a quotient rule. So we gotta take the derivative of the top, 1 dy dt because of the wrong variable, times the bottom left alone, minus the derivative of the bottom, 1 dx dt, wrong variable still, because we're with respect to t, times the top left alone, all over the bottom squared. Now the hardest part of this is I don't have secant theta. Well, at least you don't think, right? But remember, we have x and y, 3, 4. We figured out this is 5. Secant theta at this point is opposite of cosine. Cosine is 4 over 5, so secant is 5 over 4. So SOHCAHTOA. So right here, this is 5 over 4 squared times d theta dt equals dy dt is 10 from before. X is 4, they gave us. Dx dt was 15. Y was 3, all over x squared, which was 5. Sorry, which was 4 squared. Right, and then all I gotta do is multiply the reciprocal of this, get rid of it, and you get d theta dt equals that ugliness, and you are done. Let's do one more related rates question. So from 2002, a container has the shape of an open right circular cone like right here. In the figure above, the height of the container is 10, the whole container is 10. The diameter of the opening is also 10. Water is in the container is evaporating so that its depth h is changing. So remember, that's changing, so you can't plug it in to the very end since it's changing at a constant rate of that. So to tell me right there, dh dt is evaporating, so it's losing. You're losing it. That's why it's negative 3 over 10. They gave it the negative already. The volume of a cone of height, they give that, so we're probably going to use it at some point. So A, find the volume of the water in the container when h is 5. Indicate the units of measure. So A just wants you to find the volume. They give you the volume formula right there. So nothing really tricky here. We know the height is 5, so that's 5. So you get 1/3 pi. So about the radius in a second. 5. How am I gonna find the radius squared? Well, we have to do a little similar triangles. So when this, let me do a little triangle right here. Right, look at the big one. When the height is 10, the radius is 5. The big one again, we do this one. The whole container. We look at just the depth of the water though. So they're saying, hey, when my depth is 5, what is the radius? So these are similar triangles. So we're gonna set it up. So we have, I always like to do small over big. So the small side 5 over x. Small side would be x, sorry. X over 5 is equal to this side over that side, 5 over 10. The ratio is just 1/2, so x is going to be 2.5. You could cross multiply and solve it, but you get 2.5. Just half smaller. So that goes here. Squared. So 1/3 times pi. You can make that 5/2 if it makes you feel better. So 5/2 squared times 5. That's the volume. You can leave it like that. Indicate units of measure. Volume is cubed, so Just put centimeters cubed. No tricky things there, guys. Volumes cubed, area squared. Anytime you take a derivative, you add the time. Anytime you integrate, you lose it. So that's A. B, find the rate of change of the volume of the water container with respect to time when h is 5. Indicate units of measure. So B, now we're going to do a related rates question. We want dv dt when the height is 5. So I have my equation here like we had last time. Now this one gets a little tougher because I want to take a derivative of this. That's the whole point, right? To get dv dt. And the height is 5. But I don't have, if I take a derivative this way and I get a product rule, I don't have r. I don't have dr dt. Right? They give us dh dt, but no dr dt. So I have to change that radius. So you got to change that guy. And how do we do it? We go back up to here. Right, so I have 5x and then the original 510. Now again, I don't know what this is. They don't give me the 5 anymore. So let's erase all that. Right, so now all I know is that it's whatever radius and whatever height. And I got to use that as my proportion. So I'm going to put the radius over the radius, so r over 5 equals the height over the height, h over 10. Right, and again, I want to solve, in this case, I want to solve for r, because I want to get rid of it. So I'm going to figure out what r equals. So let's multiply both sides by 5. And I get r equals, this reduces to h over 2. And I can plug that in. R is now h over 2 squared h. Let's simplify it a little bit. That's going to be 1/3 pi h squared over 4 times h. And I can simplify that a little bit more to make it even easier. So the volume is going to be 1 to the 12th pi h cubed. And now I can take the derivative of this guy. Because if I integrate this guy, the derivative of this guy. If I take the derivative, I'm going to get dv dt, and I'll get a dh dt, and that's all I have. So derivative of this side is easy, dv dt. Derivative of this side is a basic derivative. Bring the 3 down, subtract 1 off. So I get 3 pi over 12 h squared, wrong variable, dh dt. And now I have everything I need. I have dh dt, which I gave at the very beginning, -3/10. So you can plug that in here. They told me they wanted to find the volume when the h was 5, so plug that in here. And then there's the 3 pi over 12. And there you go. You can leave it like that. Indicate units of measure. Let's talk about that though, right? This is volume. So volume is, we're talking about centimeters, I think. So centimeters cubed, but divided by time. Time is in seconds. What was it? Hours. It's in hours. So centimeters over hours. And there you go. Done.